Right, we're back with our discussion. I just want to refer back to a few questions. Firstly, we have made a mistake here by omitting the normal force. So the normal force must be indicated there. Unfortunately, there's only 3 marks allocated to that, so you will allocate marks for the first 3 correct. First 3 correct values, but the normal force is definitely necessary there. Then, just on question 4.3, there's again, if the learner has calculated this this velocity incorrectly, but he has substituted in there correctly the incorrect value, he will get the mark for the substitution. Although his final answer is going to be wrong, you can still award a mark for substitution. And it's also very important that we mark this direction independently. So, for instance, if this answer is wrong maybe, then you can still award a mark for the direction. Still award a mark for the direction. So, again, I repeat, yes, there's a mark if you use that incorrect value here and you mark the direction independently. And just referring to the mark allocation, if the learner, say for instance, has maybe as indicated here an incomplete, not the incorrect, but the incomplete formula. Say for instance he has make use of this formula here, but he omits 1 or 2 or an I, then we don't see it as a wrong formula, but as an incomplete formula. Then he forfeit the mark for that one. But if the formula the formula uses for delta P is correct, you can award the mark there. The principle is there's 1 mark on a formula. If we have to allocate 2 marks to formulas, then 2 out of 5 would be marks for formulas, and you can't award 2 marks out of 5 for formulas. So therefore, actually the mark is on either the formula for the conservation of momentum or calculating delta P. So if he has forfeit the mark here due to an incomplete formula, you can give him the mark at delta P, indicating this formula. Right, then moving just to question 7.4 again. It can happen that the learner maybe sees nanocoulomb as 10 to the power minus 6. And then he repeatedly is going to, say for instance, he does it in 7.4, he does it in all 3 of the calculations. You're going to penalize him once for maybe writing 10 to the power minus 6. So you're going to forfeit that mark. But if he repeats the same mistake, you're going to give him 1 mark for the next 2 substitutions. You will forfeit the mark on the final answer, but independently you will mark the direction. So you will get a mark for the direction. Right. So you only penalize him once for a wrong conversion of nanocoulomb. Right, I hope that clarifies this. Right, let's move to question 8 then. Question 8 is a question on electric circuits, and the first question is on an experiment to calculate the internal resistance of a battery. And right, the graph is given for this experiment, and the graph of potential difference, current versus potential difference. The first question is calculate V internal if the current in the circuit is equal to 0,2. Right, V internal, what is the lost volts by the time the current reaches a value of 0,2? So if the current starts off at 0 and moves to 0,2. The EMF drops from, not the EMF, the potential difference, the voltmeter reading drops from 3 to 2. So the lost volts, V internal, is therefore 3 minus 2. So there's a drop of 1 volt. So the first answer then is 1 volt. V internal with a current at 0,2 is 1 volt. And then, yeah, right, I'm going to use this. And then on question 812, calculate the internal resistance of the battery. Now, there's a few options, and I'm going to maybe add 2 options to the memo you have. They can firstly calculate the internal resistance by making use of the gradient of the graph. So the gradient is delta I over delta V, and they can take any valid values on the graph to calculate that. I've used 0,4 minus 0,6 for the current, and then the change potential difference is 1, and then they get to a value of minus 0,2, and then you must realize that the gradient is the internal resistance is the inverse of the gradient. So he must then state that the gradient is 0,2, but that the internal resistance is therefore 5 ohms. 1 mark for indicating that he's using the gradient, 1 mark for substituting delta I, 1 for delta V, and 1 for the answer. Then I maybe will move to the second one firstly. It's an addition to the memo. If the learner just writes know that R internal is calculated by V internal divided by I, so he's not making use of the gradient, and he correctly calculated delta V, say for instance as 3 minus 1, and then the change in the current as 0,2, he can get also his full marks for maybe not indicating that he's calculating the gradient, but immediately making use of Ohm's law, but making use of the correct values from the graph. He can also calculate Ri as 5 ohm. And then maybe a creative learner, knowing his maths, can also see that interpret the formula for a straight line and substitute the values. You take the values from the graph. For instance, is y his intersects. He makes use of his intersect at the y-axis as 0,6, and then use the values for I and for V. So that's the value of the current, and that's the value of V, and that's the value of the intersect of the graph at the y-axis. He can get the gradient as 0,2, and then he can also indicate that it is inverse. The internal resistance is the inverse of the gradient, and that is 5 ohm. So maybe if they relate this to the formula of a straight line, you will get to an answer of 5 ohm. So you can also award marks here. Maybe the way we allocate marks for the substitutions 2, and for the answer, final answer 1, and at the end maybe that for indicating from which formula he's working from, you can award the mark for that, indicating the formula for a straight line. Right, I hope that clarifies the calculation of the internal resistance. Then moving to question 8.2, and that's a question on the on the circuit given, circuit diagram given. All right. A circuit is connected as shown below. When switch S1 is closed, V external is 22.5 volt. So the EMF is given as 24, and here he was given V external as 22.5. The internal resistance of the battery is 0.8. Right, defines Ohm's law in words, and that you know, the potential difference across the conductor is directly proportional to the current, and that is at a constant temperature. So 1 mark for stating V directly proportional to I, and then for the condition that the temperature must stay constant, 1 mark. Then on the calculation of the power dissipated by the 16 ohm resistor. Right. Now the learner, he knows to calculate power, he can make use of V times I squared times R, or V squared times R. So actually the only possibility is for him to use this formula for power, and therefore he must realize that he must calculate the potential difference across the 16 ohm resistance. So that means V parallel. He must be able to calculate V parallel to get to the power dissipated by the 16 ohm resistor. How can he do this? Right. He can do this by means of first calculating the current, the total current in the circuit. First calculate the total current in the circuit. Why does he need the total current in the circuit? If he knows the total current in the circuit, he can calculate the voltmeter reading across this series resistor, this 3 ohm resistor. You have the external resistance, so if you subtract that from this reading, voltmeter reading, you will have V parallel. So therefore, he calculate the total current. First, he can make use of Ri equals Vi divided by I, but then he must know that the lost volts, that Vi is 1.5. We don't give him a mark in calculating Vi. We give him the mark in maybe substituting that value. And again, in this question, there's a lot of calculations for a few marks, but that is the mark allocation. We have only 7 marks to allocate in this calculation. So 1 mark for the formula, 1 mark for substituting 1.5 as V lost or Vi, and the internal resistance. So the total current in the circuit is then calculated as 1.875. Then he can calculate the potential difference across the 3 ohm resistor in series as 5.625. Then he can subtract it from the external resistance and get a value of 16.875. You will see the mark allocation again. We're not going to award a mark again on the formula for Ohm's law. So it's only 1 mark for the substitution. There's 1 mark again here for calculating V parallel, again just for the substitution and not for the final answer. Then for at the final stage, calculating the power dissipated by making use of the formula, we give a 2nd mark for a formula. Only 1 mark for the substitution of the parallel potential difference divided by R, and then 1 mark for the final answer. Right, if I can recap, there's 2 marks on formulas. He can also, if he maybe have, say for instance, omitted the formula here to calculate the total current, but he's indicated V equals IR, you can award the mark here. So because there's 2 marks on formulas. That means that he maybe have omitted, he have just indicated this calculation, but he indicated the formula here, you can award the mark there. But there's 2 marks for formulas, and then you will see for substitutions, 1 for the total current, 1 for the potential difference across the 3 ohm resistor, 1 for V parallel, and then 1 substitution mark for the final calculation. So in total, 4 substitution marks, 2 marks for formulas, and 1 mark for the final answer. Right, that is question 8.2.2. Moving to the next question, and that is now to calculate the value of R, to calculate this unknown resistance. Right. You will see that to calculate the resistance of R, you need the current flowing through R. Now at this stage, you have already calculated in the previous question the total current. So here is, you have calculated I total already. So now you can use it in the next calculation. So you have already calculated I total. Now the learner calculates the current through the 16 ohm resistor. The potential difference across the resistor divided by R. So he calculates the current through the 16 ohm resistor. Then he subtracts it from the total current, and then he gets that the current through R as 0.82. Right. And then by simply making use of Ohm's law, he can calculate by using the parallel resistance, the parallel potential difference divided by the current that he has calculated, and then there's errata on the memo. You must please change that to 20.58 ohms. Right. I think it was initially 16.06, but that is a mistake. 20.58. Please correct that. Right. To look at the mark allocation, 1 mark, you will see in this instance, there's no mark actually on a formula for R equals V divided by I, but we have already awarded marks for that also in the previous question. But so the way the memo indicates to us, it's 1 mark for substitution, another mark for substitution for IR, 2 marks for substituted the values calculated here, the value calculated here, 1 mark for that and for V parallel, and then for the final answer. So for substitutions, 4 marks. For the final answer, 1 mark. 5 marks in total. Right? That is the calculation of the value of R. Then the question where the learner must interpret what happened if a switch are closed or open or a resistor added. In this instance, the switch S2 is closed. So in actual fact, you are short-circuiting this part of the circuit. So you can also argue that you add maybe a very small resistance, but at the end you short-circuit this part of the circuit, and that means that you lower the resistance. You lower the resistance in the circuit, and then that is why there are sparks, etc. If you maybe short-circuit your car battery or whatever, because of the lowering of the resistance and the increase in the current. And therefore, the first mark in our argument is the total resistance decrease, and therefore the total current increase. if that increase, then according to VI equals I times R, that means that if I increases, then VI will also increase. So the second mark on your explanation is V internal will increase. And then therefore, because V internal increase, V external will decrease, and then stating because the EMF stays constant. So you're actually referring to the formula for stating V external plus V internal. So if V internal increases, V external must decrease. If V internal decreases, increases, V internal external decreases because the EMF is constant. So it's important that the learner refer to this part of the statement. That will decrease because the EMF stays constant for the third mark. And then the final mark for the deduction that V external has decreased. So again, you can't just award a mark, the fourth mark for stating V external decreases, because there is one mark on that statement that V external decreases, and the mark is allocated here. So the third mark of the explanation part, it's important that it must state it will decrease because the EMF stays constant. Otherwise, we have allocated 2 marks for the statement that it decreases. So 3 marks for explanation and 1 mark for the final decision on what happens with V external. That is a question on electric circuits. Right, I hope it is clear to everybody. Moving on to question 9, and question 9 is a question on electrodynamics and Faraday's law, etc., and generators. The question in question 9 is referring to generators. The diagram below shows a coil that is rotated through a magnetic field. Firstly, name the principle that is applicable here. And the principle is certainly electromagnetic induction. And then, next question, the maximum EMF is generated at position A of the rotation cycle. Give an explanation for this observation. Now, we state that in this position A, there's a maximum EMF, and we ask why there is a maximum EMF. And according to Faraday's law and Faraday's formula, that is because the rate of change in magnetic flux, is a maximum at that position. And you will realize that EMF equals that formula for Faraday that the learners do in grade 11. You can't ask anything about this formula, but it is handy for the learners to know this formula, because then you can explain using this formula. So therefore, the rate of change in the magnetic flux is a maximum at that position, and therefore the EMF is at the maximum. So 1 mark for rate of change of magnetic flux, and then that it is a maximum, and therefore the EMF is a maximum. But the 2 marks for those 2 statements. 913. Name one structural difference between a DC and the AC generator. A DC and the AC generator. Again, I think a very fair question. The learner is supposed to know this by heart. A DC generator has a split ring commutator, and the AC generator has slip rings. So 1 mark for DC generator, split ring commutator, and slip rings for AC generator. And the learner must indicate, which part belongs to which generator for the marks. You can argue that the question firstly mentions DC generator and AC. The learner maybe write this in this sequence, you can award the marks, but I will prefer that the learner indicates which generator is which. Right, that is question 913. Question 914 is use the positions indicated in the diagram above and sketch a graph of current versus position for one complete cycle. For the DC generator, indicate positions A, B, C, and D. And there on the memo, there was a slip up. I don't know how it occurs, but anyway, it has. Please correct it like this. The 2 points of maximum EMF values is at A. Sorry, just good. The 2 points of maximum EMF is at A and at C, and the 2 points of minimum EMF is at B and D. So 2 marks for maximums at A and C, and 2 marks for the minimums at B and D. And that is a DC generator, so the direction of the current stays positive in one direction. Only the magnitude of the current difference differ. So please correct that on your memo. This is the way it should be. 914. Then maybe I'll give you time just to make that corrections. Then on question 9.2, when an AC supply is connected to a lamp, it lights up with the same brightness as it does when it's connected to an 18-volt battery. That is actually the definition for what VRMS is. VRMS is that AC supply that have the same effect as a DC source. So I've tried to test this with the learners, and therefore the first question is, what is the RMS voltage of the AC supply? So the RMS voltage, then the learners must have realized that if it has the same effect as an 80-volt battery, therefore a DC source, then VRMS must be 18. So the answer then, what is the RMS voltage, will be then 18 volts. Calculate the peak current delivered by the AC source. Right, you have to your valence the power given as 60 volt. You have VRMS given as 18 volt. So therefore you can use the formula for power as P average equals VRMS times IRMS. Remember, subscripts is important. If the subscripts is not indicated, you will lose 1 mark. You will lose a mark on that formula. If you then maybe again make a mistake on the subscripts here, not maybe indicating I max, but IRMS equals I over square root 2, then you are not going to subtract the mark here. It's a repeated mistake, but the second reason is because there is no mark for a second formula. There's only 1 mark for a formula. Right, then 1 mark for the formula for P average equals VIRS, and then one mark for the 60 watts, and 1 mark for substituting the 18 volt. No mark for the answer, and then for calculating IRMS as I max over square root 2, 1 mark for substituting the 3.33, the value of calculate here, and then again the same principle. If you have calculated that value wrongly, but is substituted in here, you will get the mark. And again, say for instance, the learner has omitted this first part. He has not shown the calculation of IRMS, but he have just used a value, say for instance 18, the value of 18 here for IRMS. Because there's one mark on a formula, you can give him that mark on this correct formula. The rest will be wrong, because his substitution are going to be wrong and his answer. But he will get 1 mark if you don't indicate the first part, but only the last part using wrong values. 1 mark for the formula. Okay, I hope it's clear. So it's 1 mark for a formula, 1, 2, 3 marks for substitutions into 2 separate equations, and then 1 mark for the final answer to get you to 5 marks. If he calculated that wrongly, but he substituted here, still the mark on a substitution. And if you omit the first part, he still can get a mark on the formula. Right, that's a question on electrodynamics. And moving then along to our last question, question 10, on the photoelectric effect. I think straightforward way in asking the photoelectric effect. It's again, the diagram below shows a circuit in which a photocell is irradiated with red and blue light to demonstrate the photoelectric effect. The first question, an ammeter reading is recorded when the photocell is irradiated with red light. Give an explanation why this happened. What does the fact that red light give an ammeter reading? Why is that? And then the learner is supposed to state the following, that means that the energy of the photons of red light is greater than the work function of the metal, or that the frequency of red light is higher than the threshold or cutoff frequency of the metal used. So either referring to the energy of the photon greater than the work function, or referring to the frequency of the red light is higher than the frequency, the cutoff frequency of the metal. So make sure that it relates energy to work function and the frequency to the cutoff or the threshold frequency. So any of those 2 ways he can explain why red light, why the ammeter reading is there for red light. 10.2, blue light with the same intensity. And I've asked it maybe because of last year's final exam, the discussion about that, blue light with the same intensity, but it's important that it's now blue light. So blue light has a higher frequency, same intensity as red light is now used to irradiate the photocells. How will this influence the following? Firstly, the kinetic energy of the photoelectrons. What will happen? Using only those words. Right, blue light has a higher frequency. Higher frequency means that the photon has more energy. More energy on the photon means that the kinetic energy of the photoelectrons will be more. So it will be increase. The kinetic energy of the photoelectrons increase. Then 10.2, the ammeter reading, what will happen to the ammeter reading? The important part is here with the same intensity. So the answer will be, and the answer will be, and I just want to get to the memo, otherwise I don't show the memo to you. The answer will be stays the same, because the intensity stays the same. And now it's 4 marks, so it's actually a very complete explanation that is expected from the learners. We have allocated marks as follow. 1 mark for stating that it will stay the same, and then for the explanation, 3 marks. Firstly, the frequency or color has no influence on kinetic the frequency or color has only an influence on the kinetic energy. Right. Then intensity has only influence on the number of photoelectrons emitted. So the first 2 statements stating that frequency relates to kinetic energy and intensity relates to the number of photoelectrons emitted per unit time. And then lastly stating, but the intensity of the light stays the same, therefore the current or the photoelectrons emitted stays the same. So I think maybe this can mark difficult because learners maybe don't state it very clear. So therefore I'm just going to repeat the mark allocation for the explanation part. For him referring that frequency only influence kinetic energy, and maybe you can and then for the second part, relating intensity to the number of photoelectrons or current, either photoelectrons or the number of photoelectrons per unit time or current, relating intensity to that, second mark, and then stating that intensity in the question stays the same, and that is the reason why the current will stay the same. 4 marks for that explanation. Then 10.3, the calculation, also straightforward. The wavelength is given of the blue light, the wavelength of the blue light used, 4,5 times 10 to the power minus 7. Calculate the threshold frequency F0 if the photocells, if the average speed of the emitted photoelectrons is 4,78 times 10 to the power 5. Right, again, if the learner applies his formula correct and substitute the values correctly, that is actually an easy question. So they can indicate the equation for the photoelectric effect by either of these two ways. Even if he writes this as E equals HFO, etc. So you also accept that. So any valid equation is 1 mark. You can add maybe 1 or 2 others, like for instance E equals HF plus half mv squared. Right, then for the mark allocation, there's 1 mark for indicating, substituting the speed of light hc correctly. 1 mark for substituting the value of the wavelength correctly. 1 mark for this term HF0. 1 mark for calculating the kinetic energy, and then the final mark is for the final answer. So there's quite a lot of marks actually for the substitutions. 4 marks for the substitutions, 1 for the formula and 1 for the answer. I don't think there's any because any way that they can differ from this, because it's given values. 4,78 is given, 4,5 is given, so it's really straightforward. Right, this is then the memo. I hope it will assist you in marking and allocating marks fairly and consistently. There is a few questions, so if you just give me a chance, I will just get hold of the questions. Okay. Just referring back to a question, question 822. It can happen in such a multi-step calculation that the learners some of them may round it off. You will see I've tried to round it off at least till 3 decimals. I'm not sure even if there was more decimals, but some of the learners may round it off to 2 decimals. Say, for instance, here 1,88. And if they do that, that will have impact on the rest of the calculation. And then, for instance, this may be something else, and I have indication here that it will give you a value of 17,77 if the learner has rounded off here as 1,88. So we haven't really included a range, so just be on the lookout if the final answer slightly differs from the memo answer. If the learner maybe hasn't rounded off differently, we always suggest to the learners that they must keep as many as possible decimals in the sub questions. Don't round off too quickly, because it will have an influence on your final answer. But if the learner has been doing that, you can be on the lookout for a slight variation in the final answer. Okay. Right. If that is the only questions, MG decreases. I just want to see question 5.1, the surface area. Right. That is all that I'm going to discuss now. So if there's no more questions, I wish you a very good marking session. All of the best also for the second paper. And then after that, enjoy your week's holiday if you don't give extra classes. Thank you.